Hello everyone, my name is Manjappa GH, lecturer in Electrical and Electronic Engineering Department, DRR Government Polytechnic, Davangere. Now I am going to give lecture on VI characteristics of silicon control rectifier, different operating modes of silicon control rectifier, and two important parameters regarding the SCR, that is latching current and holding current of SCR. So in order to plot VI characteristics of SCR, we should have some circuit, that is this is the circuit we have to connect in order to plot VI characteristics of the SCR. See here in this circuit you can see we are using a DC source and it is connected to SCR through load. You can see here anode is positive with respect to cathode. In this circuit you can see, so we have connected the anode terminal to positive of the source with, through the load. And in the gate also we are using one source, that is easy, which is connected to gate circuit, gate terminal through one variable resistance and switch. By varying this resistance and by closing this switch, by varying this resistance, I can vary the gate current to SCR. See, by varying this potential divider, we can vary voltage across SCR, that is VA. It is called as forward voltage. When anode is positive with respect to cathode voltage, it is called as forward voltage, and when anode is negative with respect to cathode, then it is called as reverse voltage. Okay. So this is the graph showing the VI characteristics of SCR. It is a plot of anode voltage versus current flowing through the anode terminal of the SCR. Okay. So when this voltage is positive with respect to when anode is positive with respect to cathode, we will get this characteristics, and when anode is negative with respect to cathode, we will get this characteristics, that is in third quadrant. So SCR is having three modes of operation. It has three modes of operation: forward blocking mode, forward conduction mode, and reverse blocking mode. See, let us see one by one. In the forward blocking mode, the anode terminal is positive with respect to cathode. Okay, and in this case, junction J1 and junction J3. So these two junctions J1 and J3 will be in forward biased condition, and junction J2 will be in reverse biased condition. You can see this layer diagram here. Okay, so here once again I will tell you, here when anode is positive with respect to cathode, the junction J1 will be in forward biased condition. Junction J3 is also in forward biased condition, whereas junction J2 is reverse biased condition. Okay, you assume that. Now in this case we are plotting the characteristics by keeping the gate open. Okay, so in the forward blocking mode, we are not applying any gate current. This switch is kept open. Okay, by keeping open, we are varying this we are varying the voltage across anode, and we are recording the corresponding anode current drawn by the SCR. So we are plotting VA versus IA in forward blocking mode. Okay. So when gate current is 0, so here you can see when gate current is 0, so here, so this part of the curve, it indicates forward blocking mode. Okay. Now let us see in detail. So in the forward blocking mode, as I told, the anode terminal is more positive. It is positive with respect to cathode. And gate circuit is open. This is very important. Gate circuit is open. And SCR is said to be in forward blocking mode. In this case, we are calling SCR in the forward blocking mode. See, here in this case, the SCR will conduct a small current. Okay, when as we go on increasing voltage across SCR by varying the potential divider, okay, we are a small leakage current flows through the anode terminal of the SCR. So this is called forward blocking mode. So this current, small current, is called as forward leakage current. Okay. Next, let us see forward conduction mode of the SCR. In this mode, the forward conduction mode, we are giving some gate current. Sorry, we are by keeping the gate circuit once again open. Okay, we are varying the forward voltage greater than forward breakover voltage. Okay, the forward voltage increase beyond this forward breakover voltage. So this voltage of the SR, this particular value of the voltage of the SR, it is called forward breakover voltage, VBO. Okay, when we increase the forward voltage greater than VBO, the SCR anode current starts increasing suddenly. Okay, the current through the anode terminal starts increasing and voltage across is minimum. Okay, it is around 1 and 1.5 volts while conducting. So this is how we can turn on the SCR without gate current. That is, by increasing its forward voltage greater than forward breakover voltage. When gate current is 0, the SCR starts conducting, means the anode current increases sharply, but voltage across SCR will be minimum. So this mode of operation of SCR, it is called as forward conduction mode. It is also called as on state of SCR. Now, so we can reduce the forward voltage to SCR to turn on by increasing the gate current. Okay, suppose if you increase the gate current of the SCR, then the anode to cathode voltage at which SCR turns on reduces. So what it means here, when this is the voltage, when gate current is 0, the SCR turns from off state to on state. Suppose if I increase some gate current, if I give some gate current, okay, then the SCR will turn on at lesser voltage. It will turn on at lesser voltage. Means by increasing gate current, I can reduce the forward voltage at which the SCR turns on. Okay, this is how I can make the SCR to conduct at reduced forward voltage by increasing the gate current. Once, if the SCR is turned on by gate signal and the anode current is greater than latching current. Okay, suppose if the anode current is greater than latching current, this is the particular value of this is the current. It is called as latching current. If the anode current is greater than this current, the SCR will continue to conduct even if we remove the gate signal. If you remove the gate current, then also the SCR will continue to conduct. And the SCR in this mode, it is said to be latched. Okay, the SCR will latch in conduction only when its anode current is greater than latching current. Suppose if you reduce the anode current below some value of current, that is holding current of SCR, the SCR will turn on. Okay, means the SCR will go again back to forward blocking mode. It will go forward go to forward blocking mode. Okay, so that is called as holding current. So means once if we decrease the anode current below holding current, the SCR will turn off. So this is about the VI characteristics of SCR in forward conduction mode. Next, let us see the reverse blocking mode of SCR. In the reverse blocking mode, the anode is made negative with respect to cathode, or else the cathode is made positive. Cathode is made positive with respect to anode. In this case, junction J1 and junction J3 are in reverse biased condition, and junction J2 is in forward biased condition. In this state, the SCR will conduct a minimum leakage current, a low value of current through the anode terminal. So that is called as reverse leakage current. Okay, and if this reverse voltage increased, if you go on increasing this reverse voltage greater than the reverse breakover voltage of the SCR, greater than reverse breakover voltage of the SCR, then the junction J1 and junction J3 will break. Reverse bias, these two reverse bias junction will break, and the SCR starts conducting a heavy current. I mean, when the reverse voltage minus VA is increased more than VBR, then the SCR starts conducting in reverse direction. In that case, the reverse bias junction J1 and J3 are break, so that the device will damage permanently. So that means we should not allow the SCR, we should not allow the reverse voltage to increase increase above the reverse breakover voltage. We have to operate the SCR in a reverse blocking mode below this voltage, below VBR. Then only it is safe for the SCR. Otherwise, the junction J1, J3 will break permanently. SCR will get damaged, and it starts conducting in it starts conducting a heavy current in reverse direction. So this is about reverse blocking mode. Okay. Next, let us see what is latching current and what is holding current. The latching current, it is defined as the minimum anode current required for SCR to keep it in turn on position even after removing the gate signal. Okay. If at all, if I want to make the SCR to conduct without gate signal, once if it is started conducting, if I want to remove the gate signal, then its anode current should be more than the latching current. Then only the SCR remains in latch condition. Otherwise, it will turn off. Okay. So this is about latching current. So this latching current, it is associated with the on state of SCR. Okay, for on state we need latching current. Means if at all if I want to keep the SCR in on state only without gate signal, its anode current should be more than the latching current. So that is the theory behind that. So next, let us come to the holding current. Holding current means, so it is also the minimum anode current below which SCR turns off. Minimum anode current below which SCR turns off. Holding current is always less than latching current. It is always less than latching current. And holding current, it is associated with turn off process of SCR. Means if I want to turn off the SCR at any instant, I should decrease the holding current. I should decrease the anode current of SCR below its holding current. So this is the concept. So we are using to turn off the SCR and to keep the SCR in turn on process. Once again I will repeat. To keep the SCR in turn on condition, then we have to maintain the anode current more than the latching current, even if I want to conduct the SCR without gate signal. Suppose if I want to turn off the thyristor, which is already been conducting, then what I have to do? I have to decrease its holding current. I have to decrease its anode current below holding current. Then only the SCR will turn on. So this is about latching current and holding current. So thank you one and all. Now let us see some multiple choice questions regarding this topic. First question: in normal operation of the SCR, gate is dash with respect to cathode. Four options are given: positive, negative, at anode potential, same potential. Okay. So gate should be positive with respect to cathode. So we have to do positive gate signal. So first option is correct. And second question: an SCR combines the features of dash. First option is a rectifier and resistance, a rectifier and transistor, a rectifier and capacitor, none of the above. Correct answer is a rectifier and transistor, as it conducts in one-to-one direction. If you know direction device, that's a rectifier, and it is a gate controlled device, like how transistor is base controlled device. It is a gate controlled device. Okay, so second option is correct, a rectifier and transistor. And third question is, the control element of SCR is dash: cathode, anode supply, gate. The control element means it is the gate. SCR, we can turn on SCR by using gate signal. Next, fourth question: the normal way to turn on SCR is by the normal way means, so by giving gate current. Okay, so out of these four options: breakover voltage, appropriate anode current, appropriate gate current, dV by dt. Okay, among these, appropriate gate current is correct. So option 3 is correct. Next, an SCR is turned off by dash: reducing anode voltage to 0, reducing gate voltage to 0, reverse biasing the gate, reducing gate current to 0. Okay, so turn off process means it is reducing anode voltage to 0. If you reduce the anode voltage to 0, the anode current will go below holding current. Okay, that's why SCR will turn on. So first option is correct. Sixth question: an SCR is an dash controlled device: voltage, current, voltage as well as current, none of the above. We are controlling the SCR. SCR can be turned on by using gate current. That's why it is a current controlled device. Option 2 is correct. Okay. Next, in an SCR circuit, the supply voltage is generally dash of breakover voltage. Okay, in SCR circuit, supply voltage should be less than the breakover voltage. Okay, less than the breakover voltage. Otherwise, what happens if you do more than breakover voltage? SCR will turn on immediately. That's why the anode voltage, okay, the supply voltage generally should be less than the breakover voltage. Next, when SCR is turned on, the voltage across it is about, okay, when it is turned on, the voltage will be minimum. Okay, it is around 1 volt. Okay, and out of this 0, 10, 0.5, 1 volt is that. Okay, silicon layer SCR forward conduction voltage is around 1 volt. And SCR is made of silicon and not germanium, because silicon is expensive is mechanically strong as a small leakage current is tetravalent. So most appropriate answer is third one. That is as a small leakage current. Next, fifth question. In an SCR circuit, the angle of conduction can be changed by changing anode voltage, changing gate voltage, reverse biasing the gate, reversing the anode voltage. Okay. So angle of conduction can be changed by changing gate voltage. Okay. By changing gate voltage, you can change the angle of conduction. If firing angle in an SCR circuit is increased, the output, if firing angle of an SCR is increased, okay, the output is remaining same, is increased, is decreased, becomes 0. Okay, if you increase the firing angle, the output voltage will decrease because SCR will conduct for a smaller period. Okay, firing angle means the SCR will be in half state for more period. Okay, that's why it is decreased. Output voltage will decrease. Okay. If gate current is increased, then anode to cathode voltage at which SCR closes. Okay, if you increase the gate current, the anode to cathode voltage at which SCR closes means SCR turns on. Closes means turns on. Is decreased. Second option is increased. Third option remains the same. Fourth becomes 0. Okay, if you increase the gate current, anode to cathode voltage at which SCR is turned on is decreased. Okay, first option is correct. Okay. Thank you.